So this is the last lesson in chapter 7. This lesson involves parallel lines intersecting a triangle. So basically we're creating is what's called nested triangles. So we're going to have basically a real small triangle. I'm going to go ahead and label these two vertices X and Y. So we have a small triangle TXY and a larger triangle of TWE. Now, when we put in a parallel line, and the reason why we're doing parallel lines is because we could go back to our chapter on parallel lines. Anytime you have a set of parallel lines, there has to be congruent angles. And so angle W and the angle up here at X, they would have to be congruent to each other because they're corresponding angles. The two angles at E and Y would also have to be congruent to each other. For the same reason, they are corresponding angles. And then the angle at T is actually the shared angle. So when doing proportions for two triangles, you've got to make sure, first of all, that the triangles really are similar to each other. So these two triangles are similar by angle. So don't assume the triangles are similar, but if you definitely have a line going through a triangle that's parallel to one of the sides, then you have corresponding angles. And that's going to make the smaller triangle and the larger triangle similar to each other. So when doing this problem, once you have the picture set up correctly, you label the sides. So TY is 4, XY is A, TE is 16 because you're going to take the 4 and the 12, you're going to add together, get the entire length of that side. And then WE is 20. So as a proportion, by setting the triangles up so that they have the same orientation, so the red angles in the bottom left, the blue angles in the bottom right, we can set up a proportion by identifying the corresponding parts. So we go 16 goes to the 4, as 20 goes to A, so that's the proportion. And when we did proportions, we cross multiply. So when we cross multiply, we're going to get 16A is equal to 80. And then if we divide both sides by 16 to get the A by itself, we end up with A having a value of 5. So in this activity, problems 1 through 5 are very similar to each other. Just different pictures, but they all have parallel lines. This symbol up here of the two vertical lines, that's our parallel line symbol. So you'll see that for the first 5 problems, they're saying that the line is parallel to one of the sides of the triangle. So what I'd like you to do is complete problems 2 through 5 using the same process as we did number 1. In problems 6 and 8, these are both, all these problems are actually coming from the textbook as homework problems. Problems 6 and 8, what they're asking is are the segments themselves parallel? Is the line R and the segment AN? And so we're going to redraw the picture using the information, and then set up a proportion. We're going to check to see does the proportion actually work, and that's what we're going to do in problem 6 and 8. So we're going to do problem 6 together. This is what we did in class today. So again, I'm going to label these two points here, X and Y. So for the smaller triangle, we have GX and Y. And again, at X and at A, we're trying to decide, are those angles really congruent to each other? And we don't know that until we prove that R is really parallel to AN. So I'm not going to mark the angles in this picture, but we're going to try to set the picture up so that they look similar to each other in terms of the picture. So A would be on the same side as GX, and G and N is on the same side as GY. So for the smaller triangle, we have 15 and 25. For the bigger triangle, the left side is 51 because 36 plus 15, and the right side is 80, 25 plus 55. And what we're trying to figure out here is if I set up a proportion, does it work? So the 51 goes to the 15, and we're trying to decide if I go 80 to the 25, does it work? So a couple ways of doing it. One way, as we did the previous problem, is we do cross multiplication. So if I take 25 multiplied by 51, do I get the same answer as taking 15 times 80? If the answer is yes, then I know the proportion works, therefore R has to be parallel to line segment AN. So 25 times 51 is 1,275, and 15 times 80 is 1,200. So they don't equal each other, so line R is not parallel to line segment AN. So in problem number 8, you're going to do the same thing. You're going to set the proportion up and decide if the line and the segment are really parallel to each other, and the proportion is the fastest or best way of making that decision. So please complete the problems that have not been done for Monday.